Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 1 of seminar number 8 in the University of Debrecen for the subject of the biostatistics. In seminar 8, we are going to discuss the paired t-test, unpaired t-test, f-test, and we'll solve some examples, okay? So here, the paired t-test, as an introduction, the aim of having paired t-test, pair means I have two tests. Rather than getting one set of data, so I'm getting one set of data, for example, for the height of students, or for the diet, or for the blood pressure, or for whatever character or characteristic which I want to assess or measure, and I measure it before something and after something, okay? So before taking the medicine, I'm getting the reading of all my sample, and after taking the medicine. Before having a diet and after having the diet. So I have set of data, okay, for my sample, before and after, okay? Then I add one more row here for the delta. Delta means the difference, okay? Delta means the difference, okay? Difference. So I get the difference between before and after. So this is the first student, second student, third student, and so on. So the difference here, delta. Here, between before and after, I get the difference. Before and after, I get the difference. Before and after, I get the difference, and so on. Then I get the mean of this one. Once I put them on the calculator, I can get the mean of this set. So I can get the mean. And this set, the delta itself, it became a new set, okay? And this is actually, the delta is the main set which I'm going to deal with. So once I have the before and after, I will stop dealing with before and after arriving to the delta, okay? So once I get the delta, I deal with delta. I get the mean of the delta, sigma of the delta, SEM of the delta, SAM. You remember we mentioned before, standard deviation dividing square root of n, okay? It's called SEM, okay? So don't confuse. So if we said here the standard deviation divided square root, this is called SEM. So if you find it somewhere, it means standard deviation divided square root of n. So you can find S divided square root of n, or SCD divided square root of n. Okay, both are the same. Maybe sigma divided square root of n. It's called SEM, okay? So this is the standard error mean, SEM. So what is the purpose of having this two pair of data, two sets of data rather than two sets of data, and getting the delta of them? What is the purpose? By having two pair of data, I can eliminate, okay, or ignore any extraordinary data, okay? Any extraordinary data, or called extraneous data, okay? Called extraneous data or extraordinary data, or something anonymous data, okay? Which is not normal data, okay? Sometimes they call extremic, extraneous, extraordinary. So the thing which is odd, which is not in line with other, it can be eliminated. Its effect will be eliminated. Okay, so here very quickly we'll go through the slide. The aim of paired means two sets of data, the same set of data, but before and after. Okay, before and after. That's why I call pair, okay, together. Everything for the same person. Here for the same person, the same thing, before and after. And then we'll get the delta. Okay, pair test of data is to get rid of possible extrinsic factors. Anything factor which is extrinsic, okay? Extraordinary, that cannot change the value of the sample. Instead of performing analysis with individual observation, individual set of data, we are using the difference between two sets of data. So I'm having before and after, okay? Before, here in red, this before, sorry, in red, before and after, okay? And then get the delta, the third one. So then I will stop dealing with before, I'll stop dealing with after, and I'll deal only with delta. Once I get the delta, I'll stop dealing with these two, I'll deal only with the difference, okay? So that's why call here we use the difference between the pair of observation as a new variable of interest. This will be my interested variables, okay? And I'll ignore the other two, okay? The objective in paired comparison is to eliminate the maximum number of source of error or source of extraneous variation by making the pairs similar, okay, with respect to many variables as possible. So here, in order to get t, you remember we have t and we had z before. Z, we have the normal distribution table. For t, we have to get the degree of freedom, which is n minus 1, okay, equals n minus 1. So n is the sample minus 1. Then I get the probability, okay, or the significance factor, and I can arrive to the data. So here, the same thing which we have used in the normal t-test, we'll use here also for the paired t-test, okay? So tn or tn minus 1, as they call, equal, before we said, we used to say x minus mu, okay? Divided standard deviation, divided square root of n. Here we'll not say x minus something. We have already the delta already there, okay? So what we'll say here, we'll say just delta. Okay, it will be delta divided standard deviation divided square root of n. So what is this delta? Delta between which value? The first value, second value, the delta of the mean, okay? I get the mean of the first one and the mean of the second set of data and the delta of the means. So this is delta mean, okay? The delta of the mean. That's why I find it here delta mean, okay? Here, divided standard deviation divided n minus 1. And the degree of freedom is n minus 1. So here I have two hypotheses. What are the two hypotheses which I may have? H null and H alternative. As we used to say before that H naught supposed to be always, H alternative supposed to be always what we are looking for, the data which we are looking for, okay? And H naught the opposite, except if what we are looking for, the H alternative is equal, mu equal something. We are not going to use it. We have to use if we have the option of equal and not equal. So if it is greater than, we will greater than mu naught or less than mu naught, okay? In these two scenarios or two cases, we will use always H alternative. H alternative will be my required, or what the researcher is searching for, or what the researcher is searching for, okay? It will be, the alternative always will be what is the researcher is looking for, okay? And H naught will be, or H null will be the opposite. So H alternative always what the researcher is looking for, except if in the case of equal, mu mu naught. So in this case, H alternative, H null, it will be mu equals mu naught. Equal will be here, and not equal will be in the alternative. So always, if in the case of equal, H alternative will take the not equal. So not equal always will be the alternative in case of equal, but in case of more than or less than, so whatever given by the researcher, his proposal or his suggestion or his idea or what he's claiming, it will be under alternative always, okay? I hope this one is clear. So here, we'll stop dealing with the mu, we'll deal with mu d, okay? Mu of the delta, okay? So the mu of the delta, I have two sets of data. If I have the mean, here for example, the mean equals 15, before, numbers are different. And after, the mean also 15. So the difference, there is no difference between them. Okay? So if there is no difference, we call that mu before equals mu after. Okay? Or mu delta equals 0. There is no difference. Mu delta equals 0. So we'll assume always that mu delta equals 0 as the null hypothesis. Okay? So the other way around, that the mu delta, because alternative always does not take equal. It takes either greater than or less than or not equal, okay? So mu delta will not be equal 0, and H in the alternative hypothesis, mu delta will not be equal 0, and the null hypothesis, mu delta will be equaling 0, okay? So what if the, so I think now it's clear. So mu delta equals 0, or mu before equals mu after. Mu after equals not equal mu before, okay? So after and before, or you can use mu delta. We usually use mu d, which is mu delta. This is in case of equal and not equal. What about in case of greater than or less than? Okay, it depends on the problem itself. Okay, so if the researcher, he assumed that it is greater than, so the researcher assumption will come to alternative. Okay, and the other way will be here. If you assume it is less than, so the researcher assumption will come to here and the alternative, and the channel will be the other way around. Okay, so here the two options are available, but we are using UD mu of the delta. Okay, after solving some problem, I think it will be clear. So by having this example, everything will be clear with respect to the paired t-test. Okay, so here a researcher wanted to find the effect of a special diet on systolic blood pressure. Okay, she selected a sample of 7. Sometimes they give the number of samples in word, not a letter, so we have to be careful here. So n equals 7, so we have to read. Okay, n is given but in letter. Okay, adult, and put them on dietary plan for 3 months. The following table of the systolic pressure, blood pressure for these 7 adults before and after the completion. So here before, and this is the reading of the first one, it was 210, became 193, 180, became 186, and so on. Using the alpha, using the 5% significance, so alpha equals 5%, 0.05. Okay, level. Can we conclude that the mean of the blood pressure is influenced, okay, by the diet? Is means that it is equal. So equal cannot be with the alternative, so I'll assume that H naught will be equal and H alternative will be not equal. Okay, so if there is a change, this means if there is no change, no difference, this means that no difference between before and after, so U delta should be equaling 0, right? So I assume here that because it's equal, so H alternative will be not equal. So mu delta not equal 0. Okay, not equal 0. And in the null hypothesis, mu equals 0. Mu delta equals 0. Mu delta equals 0 means there is no change. Delta, there is no delta, okay? There is no change. Okay, and mu delta here not equal 0. So here the assumption that we conclude that the mean blood pressure is influenced. Influenced, it means that it's impacted, it is changed. Okay, it changed means it is not equals to 0. Okay, so this will be the alternative proposed. Okay. Okay, so going through the solution here, it says introduction to the solution. The question asks about if the population means before and after the treatment is different or no. So if it's different, it will mu delta will not be equal to 0. If they are the same, it will be 0. Okay. Okay, so we can write mu before equal mu after, or mu before minus mu after equals 0, or we can write mu delta equals mu naught. Sometimes they are calling it mu naught, okay, instead of mu delta, equals 0. Okay, so delta means difference, okay, difference or delta. Okay, so the mu of the difference equals 0. This is the point. So here in our problem, we said that we'll assume, because for alternative we cannot put equals. We have to put either greater than or less than or not equal. So the mu of the difference not equal to 0. So the mu of the difference equals 0 will be in the null hypothesis. The only thing which we will do, just we'll copy this table. Okay, we'll draw it again. We'll copy the table and we'll put it here. Okay, we'll move it here, and we'll add one more line and 4 more columns on the left. Okay, the first line is the delta. Okay, so we'll add here one more line for the delta. No need even to add the line for the heading. Okay, or it's good also if you want to add, you can add it to write the mean, the standard deviation, the n and the SEM. Okay, or you can add them here, the delta instead of drawing it again. You can add the delta here, one delta, and just having the delta here. Okay, and then add here the mean, the SD. Okay, so we'll have here the mean, standard deviation. Okay, n, we no need to repeat n because n is already given in the problem, no need to repeat n. And SEM, this is, as I told you, called SEM means standard deviation divided square root of n, okay? Or SCD divided square root of n. We don't need all the standard deviation for all this, so we can get the standard deviation of the mean only, because only will be dealing with the last line, the newly produced line, this line only, okay? So this is the only one which you need. No need to calculate all this. So if you are going to use the formula, even no need to calculate SEM, because SEM is the denominator here. This is SEM. SEM, okay? So if you are going to calculate here, no need to have it in the table, this column. If you have it here, no need to write it here, so you can use it SEM in the denominator as it is, okay? So if you are tied with the time, as I told you, you can have here this just two new column, the mean of the first one, the mean of the second one, and this will get from the calculator. The means will get from the calculator. Just write this list of data. I have one separate video how to use a calculator for the standard deviation and the mean. The second set, the third set, you can put them and you can get the mean of each of them. You can get the standard deviation of each of them. If you want to get the SEM or whatever from the calculator, you can write it also, but it will not be required. So then we'll arrive with a column, with a row like this row. So this is the one which we are going to use. Okay, and we will not use any other data from here. So we'll get the mean, the delta of the mean. So the mean here for the difference will be the difference. So here the difference between 210 minus 193 equal minus 17. So you have to use only one way, either after minus before, but in all the cases, or before minus after. Only one way. You don't use here after minus before, and the other one use before minus after. One way, either this column minus this column, or this line minus this line, or the above line minus the bottom line. It should be one case only. Here he's using after minus P4. So in this table he's using after minus P4. So 193 after minus 210 equal minus 17. 186 minus 108 equal 6, 168 minus 195 equal minus 9, and so on. So he arrived to the differences here, and then he put all these differences in the calculator as a new set of data, okay? And get the mean, the sum of them divided their number. So they are 7 numbers, okay? So he got the mean minus 0.5. This is called delta mean, okay? So this is the difference of the means, difference between the mean before and the mean after, okay? Or mean after minus the mean before. Standard deviation, the same thing. He got the difference between the standard deviation. So also here, what we are going to use in this formula, T equals D, the delta, D bar, okay? Okay, the delta of the means, okay? Divided standard deviation, which one? This is standard deviation first or second or the third? We'll use only the last column, the difference, okay? The difference column. So the standard deviation of the differences, okay? So SD differences, that's why they call SD differences here, if you can see. Divided the square root of n, which is 7, okay? This 2 we can get from SEM. It is the same amount, but if you don't want to have SEM, you can use this one directly. So after substituting the data which you have here, d mean equal minus 5, and standard deviation, okay, of the delta, 10.79 divided the square root of 7 equals, we got t equals 1.23 negative, okay? So my t calculated t equals minus 1.23. This is the calculated t, okay? So let us see, based on the significance level, what is the t. It is one way or two ways, one tail or two tails. It is two tails, okay? Because it is not equal, so it will be from the two sides, from here and there, okay? So the 5% will be split into two. It will be 0. The area here will be 0.025, and here it will be 0.025, okay? And I'll go to the table with the probability of 0.025, and what is the degree of freedom? n minus 1, n minus 1, 7 minus 1 equals 6. So 6 and 0.025. Let us go to the next table here, 6 and 0.025. So I arrive to this value. So my t value will be 2.447. My t will be t from the right or the left, it will be the same. So t critical here, based on the table, it will be 2.447. Okay, in this side, 2.447, and from the other side, it will be minus 2.447. So what about the calculated one? This border? Sorry, this is the one from the alpha, okay, which we got from the table. Just let me correct it, okay. So this is the one which we got from here. So what about the calculated one? Calculated is smaller than it. It will be 1.23. So starting from here, it will reach up to here only, because here minus 2.4 and here minus 1.2. So here it will reach here. It will not go inside the rejection zone. So the null hypothesis will not be rejected. Okay, it will not be rejected because we did not go inside it. So that's why we don't reject H node. So H node is not rejected. Okay? If H node is rejected, it will be type 1. If H node is not rejected, it will be type 2. So rejection of H node, it will be type 1. Not rejection or don't reject, we did not reject, it will be type 2. So here it will be type 2 error. Okay? So H node was saying that mu delta equals 0. There is no change. Okay? And we did not reject it. So there is no change. So the physician who said that there is an impact or influence or change, he's not right. Okay? So we don't support the research hypothesis that the diet influences the study. This one you can copy from the question, as I told you before. Okay? I hope this is clear. Coming to this question, in the same way, a researcher conducted a study to determine the effectiveness of reading interval pre and post assessment data for 8. Also, he give me n here in alphabetic letters. So n equals 8. Okay, what I'll do, just I'll copy this table here and I'll add new line. If the space is enough, I can add new line here. Okay, and the 2 columns at least. You can add 4 columns or 2 columns as you like. One for the mean and one for SD. Okay, as we have here. Just let us use the table which we have already. So here we list down all the data, and here the difference between each of them. He also used after minus before, after minus before, after minus before. Okay, like the same example, previous example. And here also I got the mean of the first set and the mean. So here also after minus before. So I can get the mean, or I can get the mean of the after minus the mean of the before. Standard deviation also, I have the standard deviation of the before and after. Standard deviation, I cannot deduct it. Okay, so be careful in this point. If you are calculating the standard deviation for the first set 13, standard deviation for the second set is 11, standard deviation for the third set, it is not like the mean. You can say this 55 minus 43, or you can calculate it from here. So 55 minus 43, it will give you 12. Or you can calculate the mean from here. The sum divided the number. You put them on the calculator and you'll get the mean. But standard deviation, it is not the difference. Okay? Standard deviation, it has to be calculated from the set of the data. You have to put them in the calculator and they get the standard deviation. So standard deviation minus standard deviation, it will not give you the new standard deviation. Be careful. This one cannot be get from subtraction. Okay? It has to be calculated or obtained from the calculator. Then n is common, which is 8. And SEM, which is standard deviation or sigma divided the square root of n, or standard deviation divided the square root of n. Okay, so if you will use this one, no need to have this column. If you will not use it, you can have it from here. This is the cell. Okay, because this is the standard deviation for the differences or for the delta. Okay, I hope this one is clear. So coming here to the question. Assume the difference are normally distributed. Determine whether the intervention produced higher. So what he's looking for, higher, greater than. Okay. So what he's looking for, always I make it the alternative. So H not and H alternative. So alternative will be what he's looking for, higher than, greater than, okay? Sorry, here, this alternative, H alternative. Okay, mu, not mu delta, okay, or difference, higher than what? 0. We said either it's 0, delta is 0 or no, it's not 0. If it's not 0, so it means that if equals 0, there is no difference, no change. If it is not 0, greater or less, so there's an impact, there's an influence or a change, okay? So here it is greater than, so the H naught or HNL will be mu D less than the opposite or equal to 0, okay? So the reverse of it, the opposite of it, okay? Then we calculate here, we find that T equals 6.92, okay? Then from alpha equals 0.5. We said here that the mu, the alternative, we'll go to the alternative because always we are dealing with alternative. Mu is greater than 0. So greater than means that my rejection area will be greater than. Here in any point it will be greater this side. So my rejection area will be on the right. Okay? So here it will be, this will be area will be 0.05. So and what is the degree? 8 minus 1. Okay, degree of freedom, 8 minus 1 equals 7. So I go with 7 and 0.05 and I find what T is at. Here the T calculated 6.92. T calculated 6.92. Okay, so what about 0.57 degrees 7 and 0.05? So T critical equals 1.8995. Okay, 1.895. Okay, what about 6? 6 will be very far here, okay? So it's already inside the rejection zone. So it is rejected, okay? H naught, HNL is rejected, okay? So here, reject H naught. What H naught was saying? H naught was saying that it is less than 0, okay? So here it produce higher. Since this one rejected, so produce higher is the correct one. So it supports the researcher, okay? Because the alternative now is valid. If the nil is rejected, the alternative is right. So it supports what the researcher said, okay? So it's called one-tailed, not two-tailed, okay? Or double-tailed. It is one-tailed and to the right, okay? And here, it is rejected, okay? So the conclusion that the data support the research, and we copy all from the question what is the research was saying. I hope this one clear. So since H naught is rejected, it will be type 1.